Okay, long distance ETAs. This is where it gets complicated just because you're taking ETAs and time zone problems and combining the two. Because let's say if you're crossing an ocean, not only are you going really far and you need to calculate based off of your speed and your distance how long it's going to take you, but then you need to realize that where you arrive will be in a different time zone than where you departed from. There are also going to be time zones you cross in between, but that's a problem for another time. So to break it down nice and simply, you have to take the distance you're going. Let's just make up a problem. Let's say 15 minutes north and 40 minutes west, and you're going to 20 degrees, 10 minutes north, and 62 degrees, 13 minutes west. And you're going 4,300 nautical miles. Now, these are completely made up coordinates and a distance. I don't know if this is realistic. This is somewhere in the North Atlantic, like middle of the North Atlantic, and this is probably in the Gulf of Mexico, but we're just going to assume that this is an accurate distance between the two. Now, if you're going from here to here, the first thing you got to do is, use your distance and your speed to figure out how much time it's going to be, but then you need to determine what the time was in your first location, what the time is going to be in your second location in their local time zone. So let's set this up. First, before we go any further with the D Street stuff, let's find the zone descriptions. So just looking at the longitude, 35 degrees, if we do 3540 divided by 15, we should get 2.3. So we are in ZD plus 2. Here, 62 degrees. Well, I think you can probably guess that 60 is 4, so we should be in ZD plus 4 here. How are we going to figure out converting time between the two? We'll get there in a second. First, we're going to do the distance stuff. So let's say we're doing 18 knots. We'll just write out D Street here because, like I said, this is a large enough distance that there's no use in converting it to minutes. You might as well keep things in hours. Okay, so 4,300 is equal to 18 times hours. You get 4,300 divided by 18. 238.8 repeating hours. All right. Now we have a problem of units because this is not helpful, 238.8, but that's just because it's in terms of hours. You could easily convert this to days, hours, minutes, and then be able to work more effectively off of that. How do you do it? Well, how many hours are in a day? 24. So you do 238 divided by 24, and that gets you 9.9. So you can remove 9.9 days. Well, if we remove this 0.9, because we're going to use it in a second, now we know it's going to take 9 days. Now we go back to the 0.9. We multiply that by 24 again to reconvert it back into hours because that's the remainder. So 200, let's say 9 times 24 would get you 216. So 216 of these hours turned into the 9 days. But then we have an extra couple set of hours, which we calculated to be 9 times 24, 22.8 repeating hours. So we have 9 days and 22.8 repeating hours. So we can move over the 22 again, get 22 hours. And now we have 0.8 hours. Well, how much is 0.8 repeating hours? Multiply that by 60 to convert it to minutes. We get 53.3. 53.3 minutes. So then you subtract 22, get 0.8, multiply that by 60, and you get 53.3. So going 4,300 nautical miles at 18 knots is going to take you 9 days, 22 hours, 53 minutes. We don't need to worry about the decimals of minutes there. All right, well, the one thing we're missing here is the departure time. And whenever you get a question like this, they're going to give you the exact time you leave. So let's say April 2nd at 1000. Okay, so we left at this time, 1000 local time in ZD plus 2, and it took us 9 days, 22 hours, 53 minutes. Now we need to it's easy to add these up onto this date and get the time here, but that would be the time in ZD plus 2, and you would then need to convert it to ZD plus 4. The most difficult way would then be to convert it directly from plus 2 to plus 4. What I'm going to tell you to do, it seems more work, but it's actually a lot easier, is to just work off of GMT. So before we even add these times onto the departure date, convert the departure date to GMT. So if we are in ZD plus 2 and our local time is 1000 hours, what time is it in Greenwich? Well, ZD plus 2, that means it's 1200. At 1200 GMT. So it's the same time, but in Greenwich, their clocks read 1200, and in our location, our clocks read 1000. So now that we're here, we can actually add these times together. This will be much easier, and you'll see in a second. So if we add, let's start with the minutes, 53 minutes onto 1200. 1200 plus 53.3, you get obviously 1253. Add 22 hours onto that, and you get 434. Well, there's no 34 here. What we did is we just took an additional day. So we're going to subtract 24 from that and get 10. Remember to carry the 1, just like in basic math. So now instead of 9 days, it's taken us essentially 10 days. So then we add 10 to the second, and we'll get the 12th. So we'll arrive on April 12th at 10:53. But we have to remember that's 10:53 GMT time. We don't need GMT time. We need local time of our destination. And the destination's zone description is ZD plus 4. Plus 4 is how we get from it to Greenwich. So then to go from Greenwich to it, we do the opposite of the zone description, which would be minus 4. So then if we subtract 4 hours from our arrival time, we would get 06:53 on April 12th. So in other words, if you start here and you go here, sailing 4,300 miles in between at 18 knots, you'll start in ZD plus 2, end in ZD plus 4. It will take you 9 days, 22 hours, 53 minutes. And if you add that all up from your original time, doing the proper time zone conversions, you will arrive on April 12th at 6:53 in the morning. Now, the D Street stuff is essentially exactly the same as you would do in one of the simpler problems, just on a larger scale, so you're working with larger numbers, meaning you have to convert between units more. The one thing you need to remember is before you add any of these numbers up to your original time, you have to convert that to GMT, and then at the end, you convert from GMT to the local time. You could go from one to the other, but trust me, it's just more difficult. Now, the only other thing that might play a factor here is if you were to ever go across the international date line. Like here, we're working just in the northwest But what if you were to be operating in the Pacific and cross the date line? That adds in another complicating factor. The mnemonic to remember for this is, let's just say you're going from the Philippines to California. Oh, that's off the screen. But from the Philippines to California, the mnemonic you could remember is from Manila. Oh my God. Manila to San Francisco, you go from Monday to Sunday. So basically, if you cross the date line from the Eastern Hemisphere into the Western Hemisphere, you actually subtract a day. You go from, if you were operating on Monday, you now consider yourself to be in Sunday. Because think about it, because the sun is going west, so it's much earlier in the day on the San Francisco side of the date line than it is in the Philippine side, even if they're right next to each other and you're just a couple feet away from that point. So you would be going back in time theoretically. And if you were to go the opposite direction, you would add a day.